Hello everyone, my name is Brenna Wilson and I am a 2024 graduate of Grove City College. Currently I am a master's student at the University of Florida's Department of Entomology, and today I'm excited to talk to you about how I got here, what I'm up to, and how you can prepare for graduate school as an undergrad. I started out at GCC as a pre-medical student, double majoring in English and biology, but by the end of my freshman year, I was a general biology major minoring in English. My first experience with entomology was during my sophomore year when Dr. Jenkins, who retired last May, involved me in his ant research. I spent a couple of semesters doing video analysis of interactions between Formica subintegra ants during their raids on other ant colonies, which, by the way, take place on the lawn between Lincoln Hall and Zerby. After my junior year, I participated in a research internship at the University of Georgia, during which I studied the association between habitat type and parasitic infections in kissing bugs. These two research experiences cemented my desire to go to grad school and study entomology rather than applying to medical school. In late summer 2023, I reached out to entomology professors at UGA and the University of Florida to ask if they were interested in taking me on as a master's student. And after several months of communicating with multiple faculty members at these institutions, my current advisor told me that he had sufficient grant funding to take me as a student and would support my application to the University of Florida. So I applied to UF at the end of 2023 and was accepted in spring of 2024. After graduating from GCC, I spent last summer interning at the Navy's Entomology Center of Excellence in Jacksonville, Florida, where I worked in a molecular lab to test mosquitoes for genetic mutations that confer insecticide resistance. In the fall, I moved to Vero Beach, Florida, where I currently work and study at the Florida Medical Entomology Lab. Before I go on to discuss my grad school experience, I'd like to pause and offer you a couple of tips on applying to STEM grad programs. First, I recommend that you seriously consider getting a master's before or instead of a PhD, so that you can really see what scientific research is like and get a sense of whether you want to spend the rest of your life doing it. A master's will also typically make you more competitive for admission to a PhD program than bachelor's level applicants. Second, in case you don't already know this, most STEM grad programs are fully funded. This typically means that grad students work 20 hours a week as either teaching assistants or research assistants in exchange for free tuition, discounted health insurance, and a stipend. These financial incentives can vary substantially between programs, so I suggest that you apply to multiple programs and compare their offers to make sure that you can handle your living expenses without taking on more debt. Third, start reaching out to faculty members at the schools you're interested in early, between a year and a year and a half before you hope to matriculate. I recommend that you read each professor's recent publications and articulate in your email why you want to work with them in particular. Some of these folks receive dozens of emails from prospective students each semester, and yours will be ignored unless you are sincere and tailor it to their area of expertise. Also, don't be afraid to send follow-up emails if they don't respond within a week. It's not rude to do so, and your persistence may pay off. So, once you're accepted to grad school, what can you expect? My grad school experience so far has been very different from my undergrad. First, I'm not based on a university campus. I am studying and working at a UF research lab 3 hours away from the main campus. This has some advantages. For instance, my classes are primarily online and asynchronous, which gives me a lot of flexibility for how I manage my time. However, the downside is that I interact with fewer people my own age and have access to fewer facilities and UF resources than my peers who are based on the main campus in Gainesville. Second, the emphasis in graduate school is on research first and not classes. A full graduate course load at UF is 9 credits, and the difficulty level is comparable to that of my undergrad classes. I treat my master's program as a full-time job. I show up at 9 and leave at 5 every single day. My graduate assistant duties are extremely varied because my PI's research combines fieldwork with lab work. On a given morning, I might end up driving out to local cattle farms to collect mosquitoes from our experimental traps, or pasting edits into mosquito identification books that will be used for my PI's class this March, or even caring for mosquito larvae in the lab. The picture on the right of this slide is one of the pans of mosquito larvae that I worked with this past week. After the larvae pupate, the pupae have to be separated out and placed in a mosquito cage to contain them once they emerge as adults. I do my classes and homework whenever they fit most logically into my schedule. Sometimes I'm fortunate enough to have assignments that can be completed at the same time as my work responsibilities. Most of the insects in this graded collection on the left were collected while I was out doing field work last fall. In addition to helping out with my PI's research, I also conduct my own thesis research under his supervision. I'm currently testing biologically derived larvicides on Culicoides biting midge larvae. Culicoides are problem insects because they can spread two deadly viral diseases, epizootic hemorrhagic disease and blue tongue virus, to farmed deer, cattle, and sheep. Currently, Florida farmers are using potent broad-spectrum insecticides to reduce the number of Culicoides larvae on their properties. However, I am trying to identify alternative compounds that are both effective for killing Culicoides larvae and non-detrimental to the environment. In addition to work and research, I participate in a wide variety of professional development activities. Even though I'm not on the main campus, my lab makes an effort to bring in speakers a couple times each semester. I also participate in monthly graduate research seminars along with the other students at FMEL. I am expected to attend several conferences and professional meetings each year to network with other entomologists and talk about how my research is going. For instance, last month I drove across the state for a 2-day meeting with all the other students and PIs who are funded by a specific grant from the state of Florida. I presented a PowerPoint on my research plans and got some feedback from professors. I also occasionally have opportunities to do outreach activities in the community. The picture on this slide was taken last Monday when I went to a local elementary school and gave a presentation on arthropod diversity to several groups of second graders. Now that I've told you about how I got here and what I do, I'd like to take a few minutes to offer some additional suggestions on how you can prepare for grad school during your undergraduate years. First, I cannot overstate the importance of networking. You need to build connections with people in your field. People who can recommend you for internships, grad school, and jobs, people with whom you can collaborate on projects, and people who will think of you years down the road and recommend you to recruiters when a really good position opens up at their workplace. Start out by getting to know your professors, work supervisors, guest speakers, people you meet at conferences. If you need help, talk to career services. Networking is an indispensable skill. Second, get some research experience. GCC professors often have research projects that you can get involved with. I also highly recommend paid summer research internships such as REUs and Naval Research Enterprise internships. These programs often prefer applicants who come from small private colleges because they know that you don't have as many research opportunities available to you as undergrads at major public research institutions. I have participated in both an REU and an NREAP internship, and I would be happy to answer any questions about them if you shoot me an email. Third, if you're aiming for a career in biological research, you will need a solid foundation in statistics and a decent level of familiarity with R. If you haven't already heard of R, it is a constantly evolving statistical analysis software. It has thousands of different functions, but the average biologist probably uses less than 40. The trickiest part of R is not necessarily finding the right function, but knowing how to use the platform in the first place. The best resource I know of to guide you through the fundamentals of R is a free ebook published by the University of Vermont. It's called R for Fledglings. The first 4 chapters are fantastic, but do be aware that the later chapters have some outdated code that won't work if you try to do the recommended exercises. Although R has a steep learning curve, it will pay off in your grad school applications if you master the fundamentals. The single most important piece of advice I can give to you as biology undergrads is to spend your college years intentionally seeking out and articulating your purpose. As a college student, you've been blessed with a future that could perhaps last for half a century. What are you going to do with that time? How are you going to build a meaningful life? Even if you're uncertain with regard to your career path, you can still identify guiding principles for your life and formulate overarching goals that will shape how you approach your work, relationships, and extracurricular pursuits. One of the most memorable chapel lectures I attended at Grove City was when Coach DiDonato talked about the importance of having a vision for your life to keep you motivated and grounded even during seasons of challenge or adversity. I highly recommend you check out his full talk in the chapel livestream archive from October 5th, 2021, because he did a fantastic job of explaining why you need a vision to keep you focused, fuel your daily pursuits, and help you persevere to the end. Use your classes and extracurriculars to explore different biological subdisciplines. Even if you already have a strong interest in following a particular career trajectory, I encourage you to consider alternatives. I started college 100% certain that I wanted to be either an orthopedic surgeon or an emergency medicine physician, but I discovered that I had a passion for medical entomology research, and ultimately I chose to pursue that instead. Find out where your interests lie, then ask yourself, how can I apply my passion for this subject to serve my community and glorify God? I love this quote from Friedrich Buechner. The place God calls you to is the place where your deep gladness and the world's deep hunger meet. You likely won't be able to cure cancer or establish world peace, but a single human being can have an enormous positive impact in their neighborhood, workplace, church, or county. As a biologist, you could use your career to protect human, animal, or plant health, steward natural resources, share the majesty of God's creation with others, or instruct and guide the next generation of scientists. If you articulate your vision and act with intentionality, you can make an incredible positive impact on the world, no matter how educated you become, what field you work in, or what circumstances you find yourself in. Lastly, I just want to reiterate that a GCC undergrad will prepare you exceptionally well for whatever lies ahead. Whether you go straight on to grad school or enter the workforce, you will be well prepared. I'm happy to talk to any of you if you have any questions about grad school, internships, or anything else I've mentioned in this presentation. You can find me on the GCC alumni directory or LinkedIn, and your professor has my email. Thanks for tuning in and have a fantastic day.